else is here.
Oh, I'm gonna go and see the info.
Don, you want us to leave and come back, or are we okay over here?
No, that's fine. I have to set up the live stream. I'm busy for a few minutes setting up the
All
live
right,
stream.
I'll turn off my video so I'm not distracting you.
No, that's all right.
You sure? Okie dokie. Oh, here's your wine.
Oh, yeah, that's nice.
Here,
Dessert.
give you most
Thank
of
you.
it.
Oh, how sweet. That's nice.
Where'd
Oh,
my-
you know what I'm gonna do?
Where's my tomato juice?
Behind everything because it did fit way in the back.
Max, be quiet. Be quiet.
Hello?
Can you hear me?
Yeah, mine.
Hi, how are you?
Perfectly. Phil Russamondo here.
Hi, I'm Jeff.
Hi, Jeff. My wife Marilyn will be here in a few minutes.
Okay,
Hey, Dave, I'm just getting a few things set up here.
excellent.
I posted the,
Hey, Phil.
Hello, Dave.
There's Jeff.
link to, the
This
live
may be
stream.
the way for the future. I'm getting to think everybody has to have Zoom in order to exist.
Here.
Excellent.
I mean, I meet with my friends. I teach my class.
Hey, Phil.
Hello, Dave.
There's Jeff.
Thank God I've got the lawnmower guy come by, or I wouldn't see it. Besides my wife, thank God.
Oh, well.
I wouldn't see any other real human being. I meet with my friends. I teach my class.
How's it going, Don? Dave, I mean,
I
Oh, can't complain.
one more.
Can you hear me?
I didn't see it. Besides the quiet I got.
We got you, Jeff.
Good.
I wouldn't see any other real human being.
Here's the one.
All right. How's it going, Marilyn?
Hi.
I have to do it.
He had his wine already.
Yeah, I had my glass earlier.
Uh,
We're on wine rations over here.
How's it going, Ann?
all right.
Does somebody have
How's it going, Marilyn?
the live stream YouTube going somewhere? I hear it.
Not me.
Let me check. Maybe it's coming from me.
Hey, Dave, out of curiosity, how do you get that virtual background to work where your face has not got writing on it? I mean, like Jeff, for example, he's got a guy.
What's wrong with, you see
I'm
dark
not
spots?
sure. It may have to do with his
Sparkly gray.
software and his camera. I don't know.
Do you have? They say you have to have a green screen.
I don't think so. That's one of my
There.
photographs
Hello,
in the
Bruce.
background
Hi.
there. So,
Hi. Sis.
Hi.
Hello. Good to see you.
Hello.
all
Yeah, 'cause
right.
I like
There's
several
Bruce.
of the backgrounds, but I don't like the fact that my face gets distorted.
Yeah,
Bruce, before we
backgrounds can be
start, are we
wacky.
going to have a June meeting or are we going to put it off?
I mean, John's willing to do it. So if
Should do
people
it.
want to, why not?
Should do it, yeah.
Yeah, I think we should probably have it. I don't think that this situation is going to be entirely gone by then.
Right. I'll
right.
verify with John. And I think we said, well, whatever the second Tuesday in June is. So
All right, I'll
Second
make that
Tuesday.
announcement at the beginning.
Yeah. That's,
how's everyone doing? Okay.
Can't complain. I just need my coffee.
that's what this is.
Good idea. Yeah.
Oh, we got another one.
Frank's coming in.
Hi.
Hello.
Hi, Frank. He's connected audio.
Hi, Cecilia.
Hi.
Hey, hey.
Hi, Ann.
How y'all doing?
Okay.
Hey,
Good.
Hello, Annie.
Hi.
Who's been out and who's working?
I'm working.
I'm working.
I'm working. I'm working from home.
Yeah.
Oh, wow.
I'm working at home.
Bruce, you drive in just still, do you?
No, I mean, I work from home. We
Work
go
from
in
home,
one
yeah.
day a week just to check on things, but yeah, it's all been remote. And things have been very busy actually. So
This is one time I'm thankful I'm retired. Then I don't.
yeah, really.
Oh, I'm thankful for all the time I'm retired.
Yeah, me too. Don't get me wrong.
What is your focus again? I'm sorry, I forgot.
Bruce?
Bruce.
Fine. I work for a biotech pharmaceutical company, and I do drug discovery and development for cancer drugs.
Ah,
Oh, wow.
it's like my brother.
Very cool.
He's a microbiologist. Although he's laid off now.
Laid
I'm
off,
wearing my
really?
dress sweats.
Ah.
I just finished reading his book.
This doesn't apply to Phil, but does anybody know a good barber that makes house
Barber?
calls?
I wish I did, boy.
Did they exist?
Oh my
Yeah, they're
God.
not
Barber.
A
supposed to,
barber.
they're not
I think
supposed to open yet. Yeah.
Oh,
I'm gonna.
here they are.
Yeah, yeah, right. I'm making my wife do it last resort. Either that, or I was thinking that maybe I'd take a painting of Benjamin Franklin and model my hairstyle.
Hey, Gene, you joined us. Good. Hey, Chris, can you hear us?
Yes, I can, Don. Can you hear me?
Good. Oh, yeah, I hear you fine. Yep.
Great.
Hey, Gene, I'm glad you joined us.
Hi.
How you doing?
Hey.
Morale.
Gene was in our night class along with Bernie. So this should be a good presentation, I think, about the
There
Drake
you go.
equation.
Is it this clip play or the other one?
Yeah, Scott was really excited to present this. I mean, I asked him for a number of different options, and this is the one he was most excited to talk about.
Yeah, you.
So,
Mm.
I will.
Yeah, this should be a good one. So we are live streaming the the meeting on YouTube. I hate to turn it on though, because then I get an echo. I might just check it now and then. But we
Hey,
are live
Don, I
streaming.
think your cat wants to watch this, be involved in the meeting
She
too.
wants to be on Barb's lap. That's what she wants.
Don, should we leave our voice on or should we turn it off during the?
I think we ought to all stop our video when Scott presents, because
Yeah, that makes
that
sense.
gives him all the bandwidth he can use, so we don't have any restrictions. But
Yeah.
you can mute yourself, and the easy thing to do, if you have a question, all you have to do is push the space bar, and that unmutes it immediately. But as long as you hold the space bar, it unmutes.
Okay.
Ann, do you know if Dave saw my email to him about tonight?
Yes.
All right, good. There's
Hi.
Dee.
Hi,
Hi,
Madam Secretary.
Hey, Marilyn. Nice to see you.
We
nice
should
seeing
all have
you.
letters on our pictures and we can play bingo.
There you go. That's a fun idea.
God.
Everyone healthy and the family and friends healthy, or have there been some unfortunate issues?
Well, my wife will tell you that I have many unfortunate mental health issues.
Mendel.
Okay,
We're
no
aware,
one say anything,
We're
okay?
Just
Out of
fine
respect for
about
the president.
Madam Secretary is truly in charge.
I
Oh,
I
yes.
saw a very funny cartoon. My,
No, you don't know. Just leave it.
oh, well.
Think
My
so.
wife says that we might
He
have.
told me what it
I
was.
got a good laugh out of it.
It was definitely a good laugh.
I think everybody's gonna laugh. Was
Nah.
Trump was walking towards a sewer cap that was open. He was about to take a step, and the title was
Somebody
one,
behind
one
said.
small step for man, one giant step for mankind. I thought that was funny myself.
He's stepping out yeah. If only.
So I have to say, when I was in high school, I was a member of what they call the Astrophysics Society, and we had the privilege of seeing different astronomers from a whole bunch of different schools that would come in and lecture to us at the Adler Planetarium in Chicago for 4 hours on a Saturday. And one of the people who actually lectured was Frank Drake, talking about his equation for 4 hours.
Excellent.
Wow.
It was tremendous. So this is a really exciting topic because I actually got to meet him, and we're all high school students. What do we know? But we're talking about his equation, how he came up with it, and his ideas behind it, some of the thoughts and so on.
Wow.
It's pretty interesting.
Nice.
Yeah, it is.
You gonna jump that one in your
Yeah.
computer?
Well, the guy who really popularized it was Carl Sagan on the Cosmos
Right.
series.
Because he hung out with,
He hung out
Drake.
with Drake, yeah.
yeah, Dr.
Yeah.
Drake.
Yeah.
And Sagan was another guy. I mean, we had James Van Allen came to talk to us from University of Iowa, Sagan, and I believe at the time they were both at Cornell. So they came in and spoke to us as well. It was pretty. J. Allen Hynek. It was a phenomenal. Looking back on it, it was really a phenomenal
Mhm.
experience. Guys.
Here, I'll get it. Is it Susan?
Spam. Go ahead.
Hey, Booness.
I wish I could put that on silence.
You can with a hammer.
I know, that's as far as I can go.
Boo.
There's Gary.
Hi,
Hey, Gary.
how are you?
Good, good.
Gary's there? Gary,
Good to see you guys.
we're a pretty good astronomy group. I think I like the fact that we're friends as well as members. of the group.
Right.
We're the best group, no doubt.
And modest too.
Oh, yeah.
Hello, miss.
Well, you guys.
Guys
at the
just
top are
wandered
doing
in.
good.
What, B?
Naya just wandered in.
Oh, good.
Aha.
I
Yeah,
got
when
Boo
she
in my
hears
lap.
voices.
We have a
Yeah,
boo
I
here.
think
Yeah, you
last
can
time I
see.
had to leave.
There's
Yeah.
Boo.
Oh, damn it.
Oh,
I
good.
love the background.
TV.
Yeah,
Hey.
There's Kathy.
I
Hi,
had
Kathy.
to leave because we were on two different devices in the same room and it wasn't working.
No.
No, so I'm trying to, okay.
Let's make it break.
Here we go. All right.
Kathy B,
Hi. There we
are you
go.
coming to us from Pennsylvania or Florida?
Actually, I'm still in Florida. We stayed a couple extra weeks because, well, things are a little crazy in Pennsylvania, and actually things are starting to open up here. So we felt a little more used to it down here, and we're gonna have to change our habits once we get back up there.
Right.
Wearing masks in a lot of places down here, but we ate dinner at a restaurant the other day, and you know what? It felt really good.
This was amazing. We
Yeah.
can't get out. Our son and his lady friend treated Phil and I to DoorDash an upscale, huge steak dinner. It was delicious and delivered, yes, on Mother
Oh,
4.
nice.
It was
Nice.
so nice. I even set the table. with cake.
Little bit out of the routine, and it feels kind of good, you know?
Yeah.
So where are you in Florida?
How you doing,
Orlando.
Stella?
Hi.
In
Hi,
Orlando?
Stella. How are things in the Gunshine State?
Hi, Ed.
The weather's been great. That's the other thing why we didn't come home. The weather's been great. You guys had a really cold weekend. I don't know like there now.
How you doing?
Yeah, we had a really nice couple of weeks, and you know, riding my bike, going for walks. So
Nice.
you know, it's just easier to be here right now as opposed to being in Westchester where I'd have to do all my projects.
There you go.
Everything, is everything open in Florida, Kathy?
I'm sorry, say that again, Gary.
Is everything open there?
No, but like restaurants are starting to open with like maybe 20% capacity, so you're very far between, like, you know, like if there's 3 booths in a row
I think your phone's
and the
buzzing.
other one, like the one in the middle is empty. So you're far away from people, and servers are wearing masks and mostly gloves.
Okay, I heard
Uh,
something
so-
going on.
And it depends on the restaurant, of course, but
Maybe it was
things-
someone else buzzing.
But hey, you can at least hear yourself talk in the restaurant.
yeah.
There you go. That's a
Ah,
thought.
well done.
That was a great comment.
Kathy, all kidding aside, is the average person complying with well, I guess there aren't really many guidelines in Florida, but
Well,
I mean,
actually there
are they
are.
complying with whatever guidelines there are? I thought I saw just the other day, a lot of people on the beaches.
Right. Actually, I don't mind the beaches open so much as long as people aren't playing volleyball, and you know, it's mostly teenagers, early 20s that, you know, want to get out on the beach and play volleyball and, you know, get too close. For
Yeah.
the most part, people are using the beaches for walking and exercise. And even if they're laying in the sun, they're in their family group. You usually see a couple of kids and maybe a parents. And then the next group is, you know, 6-10 feet away. So people are playing in that way. What I don't like to see is, you know, the kids playing volleyball and, you know,
Teenage hormones have been causing problems since Romeo and Juliet.
yeah. So true. So true.
Didn't they say they had the problem with the trash too? I thought I read that in
Oh,
Florida,
crab. Yeah.
the trash on the
Track,
beach.
Oh,
track.
trash.
Oh, on the beach.
Track, not
Yeah.
trash.
Yeah,
Not-
I mean, you're gonna get those you're gonna get, once people
Yeah.
get about, you're gonna get, sorry, but normal people out there doing what they want to do.
Littering.
As
Yeah.
long as they comply with the, like, you know, keep moving on the beach or stay in your group, I don't have a problem with opening the beaches. But, you know, people will be people.
Right.
Actually, Kathy, how far away from you are you from the nearest beach?
We're in Central Florida, so we're pretty far away from the beaches. But, you know, I understand, like, people live like in Melbourne, in Cocoa Beach. I mean, these are communities, and they're living next to the beach. They can't walk on it. Like, what's the difference between that and walking down your sidewalk? So again, I didn't have a problem with them opening up the beaches. As long as they, like I said, as long as they can police the kids that are, you know, trying to play volleyball and stuff.
What about school? Are the schools going to try to go back?
Not till the end, not for this year. Schools,
Okay.
most of them started distance learning. Actually, it was kind of late in the game. It was sort of like mid-April. And depending on the school district or in the school that you were in. But the distance learning or like the Zoom learning that teachers are doing started in I think mid-April. And the school districts decided not to go back. They're going to see what happens with the summer, to see what the summer looks like. But we haven't heard anything about the new school year for September. The problem that I heard, and actually Pat told me, is that he heard that DeSantis, who is our governor down here, is holding back numbers. He's holding back nursing homes. People who have contracted it and died in nursing homes. He's holding back prison numbers. He's holding back a lot of numbers in a lot of counties, and it's skewing the numbers. So
you mean he's trying
county,
to make it appear better? He's trying to make it appear better than it really is.
Yeah, exactly.
Yeah.
And that's what's scary.
I think they call that staying on message.
Yeah. Well, that's
Something
what they
like that.
did with in Japan for a while, because they didn't want there to be this big, outcry to cancel the Olympics. And then finally, it just became apparent that they were going to have to do that. And once they did, the reported numbers suddenly were much higher because they didn't have anything to hide anymore. So
Right.
After New Year's,
yeah,
they were saying that some town in China, maybe it was Wuhan, anyway, they were going to build 2 hospitals, 4 stories tall, and in 10 days. Now, they supposedly only had 8 to 10 cases. And I'm saying to myself, I don't think so. And then you find out what are you going to do with 2 empty hospitals and that wasn't the case. They were lying through their teeth.
Right. Those hospitals probably weren't so empty after all.
right.
But
I think they were
if you look at a
burgeoning.
map of Florida, you'll see like Miami and Fort Lauderdale area are still pretty red. When they color the darker the red color, the more cases there are.
Right.
And they're saying those were from the original people that came down to the beach and sort of spread it everywhere around Miami. Those counties are still pretty red. But when I look at Orange County versus Chester County, Orange County is where we are here, versus Chester County, I see that the number of cases is similar, but the number of deaths in Chester County are much higher.
But is the population density in Chester County higher than in Orange?
Well, the number of cases is what the number of tests I looked at.
Okay.
And there's a high school right around the corner from us that are testing today, as a matter of fact.
It's the reason for the difference is because Chester County is reporting the deaths in nursing homes. And if you look at the map for Chester County, you'll see the highest rates are in locations where nursing homes are located, like in Pocopson, for example.
Right.
That one is a real high percentage because we're showing the nursing homes.
Right.
True.
And that's why East Vincent is so high. They're top because of a Veterans Hospital.
And East Bradford also, there's a nursing home
Right up the street from
that's
us.
had a number of.
We're third in the county, yeah.
And that could very well be. When I look in Chester County, when I look at the number of deaths per population, it's really, really low. It's like 0.03%.
Thank God.
Is what I calculate the number of deaths per 500,000.
The only problem with low deaths is that most people don't think of them as real people, but as numbers.
No.
Real people. and one of those deaths is one of your family members. The number becomes more important.
The other advantage Chester County has compared to some of the other counties, I was involved in a Zoom the other day with the head of infectious disease control in Pennsylvania, and they were talking about first responder updates, for example, for COVID-19. And Chester County is kind of comparable to Lancaster County in that it has a much higher or less housing density as a county than like Montgomery County, Bucks County, especially Lower Bucks County, and so on in Delaware County. So one of the reasons why the cases are a little bit less, frankly, is because the density, even though the population may be similar, the density of the county in terms of close proximity is much less, you know. So, and with respect to nursing homes, Chester County actually has a fairly high population of nursing homes compared to Montgomery and Bucks County. So I think what you're going to see is some of those numbers go up a little bit. At least that's what they're saying, you know, they said in this meeting. So it's kind of interesting.
Where we live, over 70% of the cases are in nursing, which is in Marple Township. 70% of the cases are in nursing homes.
Yep.
That's pretty consistent across the board. Like in New York, 2/3 of the deaths are from nursing homes.
I just think there are no follow-on viruses waiting in the back room. I think this is better not be the wave of the future. Otherwise, it won't be much fun.
I had a cousin in Lackawanna County in a nursing home die of COVID. Yeah.
Sorry.
So, so whether or not he was counted, I assume so, but.
We've had 4 loved ones pass away since January, but they were old age and 2 from cancer, and Phil's brother passed on the 5th of March.
No, sorry to hear that, Phil.
Sorry to hear that.
Yeah. Sorry to hear that.
Part of the problem with nursing homes, though, is that there was a complete lack of PPE for the staff that worked there.
Right.
Once it got in the door, staff did not have PPE. So you wear a mask, not just to protect yourself, you wear it to protect those patients. And if you've ever worked in a nursing home, they may have a panel of complete care patients. They may have 12 of them. And if one has it and you contract it as the caregiver, you now spread it to everybody else. And they have no resistance to this. They have multiple underlying health problems. And so it's going to spread like wildfire. Lack of testing, lack of protective devices. It was a perfect setup.
Well, to your point, one of the other big issues in nursing homes was a lack of gloves. So a lot of the healthcare providers in the nursing home wore the same pair of gloves all the time. Which means
might as well wear none.
Because they weren't washing gloves, right? So you got a problem, because when you wear gloves, you're supposed to take them off after every patient contact.
You know, prior to this, every time I ever wore an N95, the second I left that room, it went in the trash. I now wear an N95 for a 12-hour shift, and it gets cleaned for 6 shifts and given back to me in a paper bag.
Right,
So they are cleaning.
Sounds very sanitary.
They were tossed, right? Same thing with gloves. I mean, so in a nursing home, they just kept wearing those equipment over and over and over again. They were just as contaminated as clothing.
Yeah, you're right.
Well, and you don't have a choice.
Exactly.
Because equipment is not available. I have more than the average person because Don and Barb gave me 4 masks. So I can rotate them out rather than having to wear them after they've been sprayed with peroxide and put underneath a UV light at the end of my shift. And the chemicals that releases when you get it back, you are choking on the chemicals.
Oh, I'm sure you are.
When you put that back on. So now I have the luxury of rotating them out since Don and Barb gave me extras, where I don't have to have them cleaned with peroxide. They can rotate out for enough period of time to get rid of the virus.
Thank you,
Is the
Don.
situation getting worse, or is it better than it was? Like, we constantly hear mixed messages.
Yeah, who knows what the hell is going on.
And we have problems. I turn on Fox and everything's great.
Well, I would say you should listen to the people that are actually doing the job.
That's
rather
why
than
I'm
the
asking
people
you.
who are on TV.
Yeah.
You know,
I agree.
Want some advice? Turn off all the news. It's all bad. You can't believe any of it.
Well done, Andy.
Andy's right.
Yeah,
Not bad.
The real issue is that there's so much unknown. Everybody speculates. I mean, what do they know about the virus? They know it's contagious. They know it's contagious, and that's it. That's really what they know. So you don't really know if antibodies give you immunity. You don't know if daylight, summertime's going to stop it like the flu, that you're going to have seasonality. Nobody really, people are speculating right now. So, you know, in a lot of ways, you know, when you're looking at the news, the only thing you can really look at is the number of testing. Then that tells you how many people they know they have it versus don't know. But bluntly, a lot of people believe that the actual number of people who have the virus is anywhere from 5 to 10 times the number that's reported. Because
Well,
some
I
people
am-
are very symptomatic.
I have been very impressed with Cuomo from New York. I think he's doing an excellent job of explaining. It reminds me of Roosevelt fireside chat, the way he talks. And then his brother came down with coronavirus, and the relationship there is marvelous. But I tell you, I would have having him run for president.
Can you aim that?
You were about to talk.
Oh, yeah.
It's in my.
Yeah, sorry, I had that when I had the little sign up.
Okay.
You know, I had
Thanks,
to-
that's better.
It's a good turnout.
Before we,
Naya.
sorry, yeah.
Hi. How you
Hey,
doing?
Don, has Scott called into you or contacted you? I saw you send him your phone.
Yeah, he gave me his phone number and he asked what time typically we start the presenter starts. I told him usually like 7:45 or so.
Okay.
So he'll sign in then and
How small do
and, you know,
these
I'll do a little
pictures get?
thing, Dave will do little things, so.
We need a magnifying glass to see
Hey,
everybody.
Steve,
Hey, Don.
good. Hey, Gary.
It's a good turnout.
Hey,
though.
Don.
We're up to 21, let's see, 22, 23, 24 right now.
And I picked up. I have
We
20.
have 3 on YouTube watching.
Oh,
So
good,
that's-
right?
We're getting close to 30 now.
Nice.
Very
Nice.
good. Good turnout.
we
B,
have on
what were
YouTube?
you gonna say?
There's Chuck Amarad, he's on. So yeah, we have good turnout, yeah.
Nice to see everybody.
Hey, Kathy. There is.
Hey, Roger. Hi, Linda.
Roger.
Hi, how's it going
Roger and Linda.
at your estate?
Has anybody been out observing?
I was out 2 weeks ago. I did see a comment.
Did you really?
I was out.
Finally did.
I was out a couple nights ago, but
Come on.
the sky wasn't that good.
Mm.
It's been windy as all get out at night, it seems.
Yeah, I got M81, M82. Went for the Virgo galaxies, but it just wasn't coming in that good that night.
How are those telescopes going, Don?
Yeah, the Dustinians.
Oh, we have 8 people interested, so I haven't heard anything back from Karen, so.
Well, she couldn't get into
She
the room.
can't get to the
She
college
can't
right
get to the
now.
college.
So it may be weeks until we
And
hear
she
anything
doesn't know
more.
how many there are.
She said 5 to 8, so we'll wait and see when we get back from her.
So were those,
Roger.
I'm sorry?
Greetings.
Hello, Linda.
Hi.
Hi.
So have you two been out?
How come we can only see the top of B's head?
There we go.
She is.
You know the thing I miss our breakfast. Now I'm thinking
Yeah.
We do
Yeah.
Missing that,
is
yeah.
have breakfast in our own home, but use Zoom so we can see each other while we're having breakfast.
Yeah. You sit up, you're slouching.
I'm worried about Steve Lyden. I think he's going to starve to death.
Haven't been on any of the calls at all. I don't know what's
Yeah,
happening
he
with
has
Steve.
fear of Zoom.
But that, yeah, we have on YouTube. So
Steve has fear of Zoom. Who said?
I think he does, yeah. All right, there's Scott. He's coming in.
Manoia.
Hello.
Hi,
That was
Scott.
good, Dave.
Hey,
Hi, how are you?
good to see you.
Hello,
How are the
Scott.
kids?
Doing all right. Hope I'm not too late.
Are you
No,
sleeping,
you're
Scott, at
actually
all?
early.
Good.
First of all, thanks for agreeing to talk with us, especially when we had that little emergency with our poor member who broke his ankle back in,
Yeah, for
that
No,
was
no
really
problem, no
great.
problem.
He's the speaker too.
Sorry, I'm outside. You hear that? Sorry.
All right, we're only at 7:24, so we'll wait till right around 7:30. And then what we'll do is ask everyone who's not speaking to stop their video and mute. And if you have a question, Scott, will you take questions during the presentation?
Sure.
Okay, so the easiest thing to do, if you mute yourself, then when you want to ask a question, all you do is hold your space bar down and that unmutes you temporarily. Rather than having to find the icon and click on it and unclick on it, just use the space bar to ask questions. So
And do you hold the space bar down the whole time
you
you're
hold the
talking?
space bar down while you're talking. Yep.
Okay.
Yep.
Okay.
Hey, Sue.
Hey,
Nice to join
Hey,
us.
hi.
Hi.
Happy birthday again.
thanks.
Oh, you had a birthday?
Yeah, Sunday.
Oh, cool.
Happy
Mother's
birthday.
Day.
Thank you.
Wow. We won't ask how many.
That's good.
She's
Hi,
not
Good
gonna
Janet.
tell.
Hi, Janet.
Hi, Janet.
Hi.
Are you in Philly?
Greetings.
You down in Philly?
Yes, I am.
Okay, sequestered in Philly.
Yeah.
Janet, I was thinking about that show that we saw at the art museum with you. And I
Right,
am so glad we caught it and caught it when we did.
right. Because after that, wow.
It wasn't
Yes.
very many days, yeah.
Mm-hmm.
And they were lucky they got the flower show in too.
Yeah.
Yeah, just.
Right
That
under
was
the
nice.
wire, right?
Mm,
The flower show is probably right under the wire.
It's
Yes.
just before this all
Right.
the
Yep.
Yeah.
craziness broke loose. Yeah. You know, like 2 weeks
I
later,
missed
they
it.
closed everything down.
First week of March.
Yeah, I missed that.
Hi, Jim.
How long have we been in here now? How long has it been?
Month.
Since
Oh,
15
2
days.
months.
2 months?
15 days.
Gosh almighty.
Hi.
That's
It's been a little over a month and a half.
months.
We went
You
for
know, I
2 weeks.
we went for a hike with a friend of ours today, and he said to me, "Ask me what's new." Not a goddamn thing.
Yeah,
the feeling.
one thing about this, I always know what I'm gonna do when I get up in the morning.
Uh-huh.
Well, what do you do after you pee?
That's at 4 a.m.
I tell you.
Oh, you too?
Uh,
Why is it so
life
cold?
has become so predictable.
Why is it so cold in nearly the middle of May? What is wrong?
Hey, where I am, it's like 85, so it's not cold at all.
Oh,
many
Hey, rub it in,
Was that
Kathy.
Florida?
Yes, Kathy's
It's gonna
in
be 80 on
Florida.
Friday.
That's
Crater.
Wait. I'm gonna make y'all jealous.
Oh.
Actually, that's my moon background showing up in the
It's
wall.
a swimming pool.
It's a swimming pool.
Okay, Kathy, we hate you.
It's going to be 80 here on Friday. So
Yeah, flowers.
But not.
Oh,
with
really?
Yeah, it is.
Mhm.
Yeah.
yeah.
Yeah, well, we're coming
So,
back.
Dave, you
Bringing
changed
it with
from
us.
the Aurora to the Vale.
Yes, I did. And I'm about to change again.
It's going to be 80 here on Friday?
On
Yep,
Friday.
yep.
And it's low, yeah, like 80, 81. Yeah. And it's going to go almost frost tonight, down to 36 or so.
Yeah, so
Wow.
cover your potato plants.
Yeah. Cover your potatoes.
Yeah, we lost 4 of our tomato plants
Mm-hmm.
over the weekend.
Oh,
really?
Rats.
Haven't
And
given them a
I-
decent burial yet.
Did it have coronavirus?
Our potatoes got nipped, but not killed. So I covered tonight.
Blankets on my I have palm trees in my front yard, so I had to put frost blankets on them.
Palm
Oh,
trees.
Lord.
Wow.
And I've got 3 palm trees. My wife thinks I'm nuts, but they've lived so far 3 years.
Good.
You get coconuts?
Wow.
So what do you cover them with?
I think the biggest surprise I got when we went to Ireland was that how many palm trees there were in Ireland.
In the southern
Palm
part,
trees?
yeah,
Oh, my.
yeah.
What
Wow.
are these things doing here?
I would never have guessed that.
It was a
That
shock to
doesn't
us.
seem right.
It really doesn't.
Yeah.
So when were you there?
Let's see, the last time we were there was about 3 years ago, yeah.
Okay,
We were there for a wedding.
nice.
Okay,
Was that Liz and Gordon?
I don't see them.
No, no.
Oh,
don't see them yet.
I was thinking about the wedding.
Oh, no, they didn't invite anybody.
No, that was our neighbors.
Scotland, never mind.
Mm.
Okay, Don,
Yeah, it's 7:30. I think we can start getting rolling. We're live
But
on
before
YouTube.
people start turning things off, Don, I'm going to take over the screen here for a minute because I have a couple of announcements and I think I'd like to take over the screens to do them.
Okay, and everybody should unmute at some point.
No,
too.
yeah, everybody unmute and keep your video on. Okay.
We're not muted.
Oops.
You have to pick the right window, Dave. Just stop sharing and join. Do it again. So stop sharing top of your screen and pick the right window this time.
Let's see. What, just click on it?
Click on share screen again and then click the right window, the window you want to share, yeah. You just clicked the wrong one that time. It'll give you a choice of windows.
I think this was what I wanted.
Click on it and
nope.
no, you gotta get the other, it's another screen you want to get. It'll give you a choice of windows.
This better be good, Dave.
It is.
Oh, it will be, trust me. Let's see.
Get your IT person next to you to help out there.
IT clueless.
No, what it's doing is it's going to this thing.
There's another screen you can click on. Well, just go to the bottom of your, go to your normal screen, go to the bottom and click on it then. Share your whole screen and then just select it like you normally would.
And hit share.
Okay, now go to the bottom like you would normally pick any other one and pick. What
Yeah,
you
you
want
can
down the bottom.
minimize, yeah. Yeah,
Yeah,
just
pick,
from here.
pick whatever you want at the bottom, yeah.
Yeah.
Like you normally would.
I don't see anything at the bottom.
What are you trying to share? A PowerPoint?
Do you have your app open?
Yep.
You should be able to just, when I put share screen, it shows me multiple things to pick, whatever's open. So you should be able to pick, it should give you a choice of screens that are open at the time.
It just says screen.
From here, does that like your desktop? Could you minimize this and then find what the icons across the bottom?
Yeah, try minimizing that and see what else you can find.
Do you need to open the article
Right.
first? You need to
All
open
right.
it first before you share it?
It needs to be open. Yeah, whatever you want to share has to be open already on your screen somewhere.
It's not doing it.
So minimize that.
So when you hit, you should see a bunch of little rectangles of all your different screens that you have open.
Yeah,
So you gotta
I
find
do.
the right- It's kind of toggling amongst them to find the right one.
What you can do is close down everything else than what you want. It may give you, maybe there's too many open.
Maybe I do.
Yeah,
I wonder if I can.
close down your email and things like that, and just have only what you want open.
It's when I go to screen, there's a blue thing around all the icons of all the images of you guys, and it's not coming to that for some reason.
Well, you may have to just.
I'll tell you what, well, we'll just do it this way because there's just a couple of things. First of all, as you mentioned, there's at least one birthday here. But there's another birthday that I think that we should probably include, and it has to do with our vice president. So if we could all wish a wonderful happy birthday to both Sue and Pete.
Happy birthday.
Happy birthday, Pete.
Happy birthday, Sue.
Happy birthday.
When's your birthday,
Happy
Pete?
birthday.
17th.
Ah,
So anyway, we had, how many is it, Pete?
Let's see now. Too many.
not me, Pete.
It's something less than 96, I know that.
Not enough, not too many, not enough.
Happy birthday.
And the second thing that I'd like to do as president is one of the best parts about this job is to present awards, especially from the Astronomical League. And I would like to recognize tonight our own Frank Angelini, who informed me today that he has completed the Astronomical League Double Star program.
Ah, wonderful. Yeah.
This is one that I believe that it's 100 double stars that you need to be able to log and put in an observation book and turn that into the AL. Is that right?
Yes, that's right.
So congratulations, Frank. I understand you have a couple of other irons in the fire on the AL League, that you're well into the Herschel 400 Club.
Right.
And do you think you'll have the asterism done soon?
Yeah, I just finished the asterism observing program, which is really neat. Although you have to use your imagination, there are some interesting asterism is a grouping of stars or celestial bodies that suggests a thing, like a sailboat or a shovel or a gun or whatever. And
is the martini glass in that list?
No, it's not.
well, there was no martini glass, but there was a
the coat hanger.
There was a jug.
Right.
There was a liquor jug. Yeah. Yeah.
Was that an asterism, or was that something you had out at the telescope?
I'll have to submit that for approval.
How do you
Oh,
do
wait.
it?
Well, anyway, congratulations, Frank, and we look forward to seeing you get the upcoming awards, especially the Herschel 400. That one's a real bear.
Well, I've been working on it since 2009. So,
How long did it take you to do the double star program?
Well, this is a little embarrassing. I started in 1997.
Okay, that's determination.
Yeah, then I had a change in my career and I started traveling a lot more. And so I had to put that aside for a while. But
well, congratulations for finishing it and keep up the great work.
Thank you, Dave.
Congrats.
Now, the other thing that I would like to share with the group before I turn things over to Don is that we have decided that we are, in fact, going to deviate course a little bit. We are going to have a June meeting, since it's very likely that many of us will still be stuck inside. And one of our frequent speakers has agreed to
she could do something
to actually ignore his broken ankle and is willing to give us a June meeting. So we're going to
we crash, the whole meeting goes away. You can't let
so
it go back there.
there will in fact be a virtual meeting in June, and we hope to see you all there. So I'm going to turn everything over. Oh, and the other thing that I would sort of like to announce, if it's okay with you, Don, is that all observing dates and things like that may be sitting out there on the website and things like that, they are canceled until the COVID situation resolves.
Yeah, everything canceled.
Okay, Don, take over.
All right, I'm going to do things a little different tonight. Rather than just looking at the sky like we would normally do for a few minutes, what I'm going to instead is show you this. This is called NASA Treks. Does everyone see this coming through?
Yes.
This is an amazing NASA site. I'm only going to do a real brief look at it because I haven't really had time to spend a lot of time on it yet. The last NASA Night Sky Network talk was about past and future lunar landing sites. And the fellow who did that spent a lot of time on the moon. So it's some pretty cool stuff here. You can do explore the treks. And just to show you briefly what some of these things are, water solar treks, they're online portals that let you look at, a number of different objects in the solar system. It's really, a lot of it's brand new, like some of these things are in beta. They're not even out yet. There's all kinds of stuff we can do here. Let me just minimize this little window here. If I go to home, and we go to explore the treks, here are the choices we have right now. I'm just going to show you the moon. The moon is pretty cool, and just the graphics alone are amazing to watch. We're going to land on the moon here. So when you think you're Apollo 11 now, this coming through okay?
Yes.
Yeah, we see.
This is all this imaging is from the Lunar Reconnaissance Observer, and it's as close as you can get to be in there. All right. So that was just the intro. Here's the actual. Here actually loads of program. There's a tutorial which we're going to skip. I went through it. It's not too hard to use. Main thing, we go up to this button called Data, We can go to Apollo 11, gives you information, but most fun is to fly to the area. And here is the actual lunar landing site. I'm going to zoom in slightly. And there is the leftover descent stage from the Apollo 11 mission. All these little spots here are data packages that were left. You can zoom into the point where you lose resolution. I'll zoom in one more time, but these are the actual footprints on the moon. So pretty amazing stuff. Pretty amazing stuff.
Very cool.
I'll go back to
Looks
data again.
looks like you could see the feet on the lander.
Yeah.
I think you can. I think you're right, Kathy. We can go to Apollo 12 is another fun one. I'm going to fly to that area. And earlier, here's the actual landing site. This is the Surveyor spacecraft that they visited. You can sort of see here the footprints. They went to visit the Surveyor. So it's really an amazing program. I'm just barely scratching the surface on it. We go back to, so I want to get back to the home page of it and see how I do that. We'll look at one other one. And that will be Mars. Mars is pretty cool too. These are the only ones I've really explored. We're going to land on Mars. And all this is from the Mars spacecraft. I just love this landing. This landing imaging is amazing. But we can see things like where the Curiosity rover is at. So it's just trek.nasa.gov is all you need to put in. I'm going to skip the tutorial. And we'll go to the Curiosity landing site. There's Curiosity, and we'll fly to that area. So this is where around here, I haven't found the actual lander yet, but this is the area that the Curiosity rover is moving around. So I think that's all I have now to show. So Bruce, I guess I'll turn it over to you. And I guess one thing we should all do then is stop our videos and then mute so that Scott has all the bandwidth he can use, okay?
So I want to welcome Scott Engel to speak with us tonight. As many of you know, Scott is from Villanova. He's been a longtime friend of CCAS. And one of the areas that Scott is most interested, or one of Scott's many areas of interest, surrounds the Drake equation, which we're approaching the 60th anniversary of its design. And so Scott is going to talk tonight about sort of revisiting the Drake equation, what we can learn from it, some of its implications, how we're using it to make estimates of the potential for advanced extraterrestrial civilizations out there. So I thought this was a really kind of interesting and intriguing topic to discuss. And Scott's probably the best guy to tell us about it. We also need to congratulate Scott. He's a new dad again, so I'm not sure how much he's sleeping, but congratulations, Scott. So welcome and thank you. Thanks.
Thank you. How does the audio sound for everyone? At least anyone who's not muted.
Sounds real good.
Very good. Sounds good. All right, good. All right, let's see here. Let's do a share screen. All right, and all the little windows popped up, so that's good. All right. Oh, just a quick one. All right. So usually Dave asks. So here is that was her that's her 1 month picture.
That's just adorable.
Yeah. She turned 2 months old today.
Adorable.
But we took her 2 month old pictures today, but I haven't, they're not, I didn't get them ready for this. So there's her 1 month picture from a month ago.
Oh, she is
beautiful. So there you go.
How many girls is that now?
So I'm sorry, what?
How many girls?
Two.
Oh, that's great. Thanks for sharing.
Yeah, sure. All right, so let's get to the presentation now. All right. Slideshow. Okay, started up all right for everyone?
Yes.
Looks good, looks good.
All
Yes.
right, perfect. All right, so thank you very much for having me. As Bruce said, we're going to talk about the Drake equation today, immersed in uncertainty and frustration, yet still informative and oh so interesting. So that's the big thing about it. The Drake equation was first put forth in 1961. Francis Drake, he was calling forth a meeting of a few interested minds. Carl Sagan was there. They were going to be starting up some searches, basically, the formation of SETI, and trying to figure out, what did you need to get together? What did you need to gather up if you were going to try to make this, serious business? If you wanted to come up with just a rough notion, was anybody out there? Was anybody either trying to talk to us? Was it possible to talk to anyone? Was there extraterrestrial intelligence? And could you try to actually get an estimate of the number of civilizations out there? And there's obviously a huge range of answers. It's the whole immersed in uncertainty portion. So the very first thing is that there is no real answer to the Drake equation. If you want to have the technical answer to it, the real scientific answer, then people like to say, well, of course there's intelligent life there. There's people on Earth. Simple as that. It's the only scientific answer to the Drake equation. It's also sometimes simply known as the smartass answer, which some people enjoy putting out there. But what's good about the Drake equation is that it's a thought exercise. What parameters do you need to put in place if you wanted to try to figure out beyond the Earth? Can we take the data that we have here and in our neighborhood, what we've been able to glean from the universe itself, and what have we been able to get primarily from the Earth then? Three different fields of science that basically form up astrobiology. Astronomy, clearly, planetary science, and then biology, naturally. And can you extrapolate any of that outward into the cosmos? And can you get any real answers or at least real estimates to this notion of is anyone out there, or at least what is the likelihood of it? So that's what the Drake equation is really useful for, is for guiding this conversation. It's like the synopsis I said, it's just hotly debated. Some people think that it's completely useless, and that's always wrong. Anything that gets scientific conversation going is always useful. Even if there is no rock solid solution to the Drake equation, it's still a very useful thing. It's always good to get people talking about science, even if it simply gets them talking because it frustrates them. You still want people discussing it. So let's start off with listing not the original equation as Drake put it forth. At the time, Drake was going off of what was considered the steady state model of the universe. He had parameters in there such as how many stars per year were being formed within the Milky Way, and making assumptions about how many of those stars were then dying per year in the Milky Way, things like that. So we'll go off of a modified version of it. What you want to form up naturally are n sub civilizations, the number of civilizations that are out there that you could potentially communicate with. What's on the other side then, would normally be on the right-hand side of the equation in this slide at the bottom here. How you would calculate the number of civilizations. First, n sub HP. First, you want to figure out the number of habitable planets out there. Multiply that by the fraction of those planets where you believe life has arisen. Multiply that fraction of those planets then where that life makes it to civilization. Multiply that by then the fraction where they are alive right now. So how many are currently alive? How many have still survived to the point where we can communicate with them at this point? That is also even debated, because they don't still need to be alive if you're simply looking for life elsewhere. You just need to be able to receive radio communications. just answering that simple question, is there anybody else out there in the universe, is a huge, fundamentally important question within the sciences. So just receiving proof of intelligent life elsewhere, F sub now can be removed from the equation. You just need that rock solid evidence that life exists elsewhere, and that is a huge game changer. They don't still need to be alive. Yes, obviously you'd love to get back and forth communications going, but so this is the equation that we'll be focusing on in this talk.
Hey, Scott, when you say now, the F,
Yes,
the function of now, is that our now?
that would be depending on their distance from us, and now would imply that we could get back and forth current communication going. So if they were,
That's talking
10
like
light
within
years
our
away,
solar-
then they were alive, they're still going to be alive 20 years from now. So we get a signal from them, we interpret it, get a response back to them, 10 years back and forth. So they're alive for another 20 years. So we can actually get our response to them and hear back from them that yes, two-way communication was established at least once. That would be the, roughly the F now. But like I said, it's not necessarily important for the equation if you simply want to know that somebody is alive elsewhere, or at least was, beyond the Earth. Did I answer the question? Ah, good. Okay, so this is the equation that we'll be focusing on then. Let's get into the actual parameters and themselves. First one, NHP, the number of habitable plants out there. It is, without a doubt, the one that we have the firmest grasp on, and a huge amount of resources have been dumped into not simply establishing this parameter for the purposes of the Drake equation, but just because it's a huge scientific question. It has a great deal of public interest. It wasn't too long ago, just in the 1980s, things like that, and even into the 90s, where planets beyond the solar system were completely theoretical. Just early in my own career, shortly after I received my bachelor's and I was writing up proposals for satellites, and planets had already been discovered around a limited number of stars. And I was proposing for a satellite to observe M stars, which is one of the stars I studied, stars that are cooler and dimmer than the sun. And nowadays we know of, hundreds and hundreds of planets that orbit them, but none had been found yet. And so we had proposed to observe some of them in ultraviolet light just to see if they would be, good targets to have planets around. Maybe you'd have life around some of these planets. And we got the proposal rejected. And what the panel told us was they simply said, no planets have ever been found around M dwarfs, and we don't think they ever will be. And so that was only maybe like a decade and a half, 2 decades ago, something like that. So it wasn't long ago, And so it's crazy just how rapidly this field has changed. But the very first parameter, the very first variable we're going to start off with, it's the one that we, without a doubt, know the most about, has the least uncertainty associated with it. Because, well, we're talking about just the Milky Way galaxy that we live in. Here is our, artist rendition, obviously, of the Milky Way. The issue with even this parameter is that if you talk about, the local group of galaxies, the big three, the Milky Way galaxy that we live in, major spiral galaxy, Andromeda, major spiral galaxy, M33, the great spiral in Triangulum. They are the three major galaxies within our local group of galaxies. Andromeda and M33, we know much more about them than we do about the Milky Way. It's taken us a very long time just to figure out the exact properties of the Milky Way, just how many stars there are to it, exactly how large it is, exactly how massive it is, exactly how many stars there are to the Milky Way, because we're living inside of it right now. This is actually a pretty timely time to bring up this question, because we're all on not house arrest, but stay-at-home orders. And you can imagine that if you have lived your entire life within this house and somebody asked you to describe the outside of it, or somebody asked you to describe in detail, exactly what it looked like from the outside or all of its properties, you have a pretty difficult time with that. So it's actually taken us a good long while to figure out exactly what the Milky Way looked like and its entire stellar content. But up to this point, especially thanks to infrared satellites and infrared astronomy that's been able to peer through a lot of the gas and dust and to see into the core of the Milky Way and onto the other side of the core of the Milky Way. We've been able to discover the outer arm of the spiral galaxy, things like this. We now know there's about 200 to 400 billion stars within the Milky Way galaxy. So only a factor of 2 uncertainty in the number of stars in the galaxy. This is the most precise parameter that we have. So if you're going to figure out how many planets there are, the first thing you want to start with is how many stars there are. Because if we're trying to figure out, habitable planets, we could get into the most extreme situations that life could start to arise under. But obviously, we're going to concentrate on planets orbiting stars, getting enough energy, enough warmth, so that what we would generally consider favorable conditions for life will then arise. So start off with number of stars then, 200 to 400 billion within the galaxy. Moving from there, is the entire galaxy then habitable? Is every single star in a galaxy good, or at least potentially habitable for life? Now, you're going to hear this all throughout the talk. As it turns out, this topic is still debated to this day. Astronomers disagree. For most of history, or at least most of, ever since this topic was brought up, there is also believed to be a galactic habitable zone where the inner core of the galaxy is believed to be no good, believed to be uninhabitable. As you get into the central region of the galaxy near the galactic core, stellar density increases, the distance between stars shrinks down, so the chance for gravitational interactions goes up. So you could have planets being stripped away, or at least their orbits be destabilized, debris from either Oort clouds or things like that. So impacts can rise up, the chances for them. So for a number of reasons, the galactic core is thought to be, if not uninhabitable, at least less favorable for habitability. Also, because stellar density increases in the inner core, supernovae are thought to be much more common in the inner core. So the radiation that supernovae would give off, the energetic events, start to decrease the chances for habitability in the central region of the Milky Way. Then, when you move to the outer region, there is a different problem. Naturally, things settle down. Stellar density drops off, so you don't have the radiation problem. You also don't have the gravitational interaction problem. Everything sounds like it's great. This brings up the problem of the chemical enrichment of the galaxy over time. As stars come online, are born, live out their lives, and die. The very famous Carl Sagan quote, "We're all made of star stuff." They take the original, primarily hydrogen, some helium that they were born in, churn it up into heavier elements, what we just call metals, simple as that. Carbon, nitrogen, oxygen, these are all very, very important if you're going to try to make planets, and especially if you're going to try to make life. They die, distribute that into the next generation of stars that'll be born after them. Now, here in this plot, you can see I have it overlaid on, a side-on view of the galaxy. So on the x-axis here, radius, that 0 point there, overlaid right on the core of the galaxy, and then moving out to the edge of the galaxy. What you see on the y-axis here, this z, log of z over z sub, O dot, or basically what you're talking about is the metallicity content, the amount of metals that are present as you move from the center of the galaxy out towards the edge. And you can see that at all these different ages, 2 billion years, 4 billion years, 6, 8, 10, as a galaxy gets older and older, the amount of metals keeps on rising up. Now you want those metals. You want carbon, nitrogen, oxygen, because you want to have enough rock, enough metal, enough iron, so you can actually build planets out of it. And so that you can also build life forms, carbon-based life forms, things like that. The core of the galaxy gets enriched by these metals first, because it has so many stars coming online and dying, supernova explosion, seeding the next generation of stars with all these metals. So that's great. Hopefully you're able to form a lot of planets, but we don't think the core of the galaxy is favorable. So we don't think it's necessarily a habitable place. Out at the edge there, it takes a very, very long time for the edge of a spiral galaxy to get metal rich, if you will, or at least just to simply not be ultra metal poor. So we wonder if the edges of spiral galaxies are going to have enough metals, enough rocks, things like this to build terrestrial plants, or at least to build them in, high enough numbers to make them favorable, habitable places. So we think that the cores of spirals are less than favorable. I think the edges of spirals are also going to be less than favorable places. This means you're going to probably left up with this donut, this annulus, nice little ring, roughly in the middle of spiral galaxies. Something like this. That's going to be the galactic habitable zone. So the current view, majority view, but as I said, still debated, as almost everything with the Drake equation is, that not all of the galactic stellar content is going to be considered within the habitable zone of the Milky Way itself. Somewhere, roughly right in the middle of the galaxy. Just so happens to encompass where the sun is orbiting in the Milky Way, which is good for us. That's going to be considered the galactic habitable zone. Works out well. But it's always a numbers game. Is it going to be possible that there's going to be planets within the core of the galaxy that have survived gravitational interactions, that have survived nearby supernova explosions, things like that? Of course. Is it going to be possible that planets can form around what we would consider metal poor stars? Yes, we know that's actually possible. Why? Because a couple of the closest stars to the sun, in fact, a couple of M dwarfs, one called Kapteyn star, one called Barnard star. Barnard star is a member of what we call the old disk. It's about 9 billion years old, 10 billion years old, something like that. It's pretty metal poor. Kapteyn star is actually a member of the what we call the halo population of the galaxy. It just so happens to be very close to the sun right now. It's a member of the halo. The galaxy is roughly spherical. Population of stars all around the Milky Way. It formed so long ago that the Milky Way had not yet taken shape as a flattened spiral disk. So Kapteyn star just has this random orbit, and it just so happens to be moving through the disk at this point, so it's really close to the sun. Kapteyn star is around 11.5 billion years old. Kapteyn star is very, very metal poor. On this plot, Kapteyn star is right down at the bottom. Kapteyn star has super Earth planets orbiting it. Barnard star also has super Earth planets orbiting it. We found them. So there's two examples. There's single stars. So do we know that the outer regions of the galaxy are going to be still, favorable places to look for habitable planets? No, I don't know if they're favorable, but we do know that we have found, well, not necessarily super Earths or something like that, but based on their radius and mass calculations, they can be terrestrial planets. The sizes would work out that they could be terrestrial. And they are orbiting very metal poor stars. So this is why even something like the galactic habitable zone itself is still debated within the field. Now, getting past just the numbers of the stars themselves, as we're whittling this down, now we move on to the planets that are orbiting them. How many stars are there within the galaxy? That was what we know the most about, actually. Moving on to the planets, this helpful little mission here has been the biggest help that we've had. This is the Kepler satellite. I'm sure you've heard talks about Kepler before. Kepler simply, in its originally envisioned mission, sat there and stared at 100,000 or so stars within the Milky Way galaxy for several years at a time, and just waiting for planets to pass in between us and the star, causing a small little dip in light. So what we call the transit method of finding planets. Found a few thousand, either confirmed or still potential ones that are awaiting confirmation. So we have a massive number, once again, either known or still waiting confirmation planets. And because so many astronomers are working on it, all of what we would call, the systematics of Kepler were really well worked out. we knew the selection effects, the biases that affected the instrument, the satellite itself. We knew just which ones it would be able to see, which stars Kepler couldn't quite observe planets around. So it was a really well characterized system. So even though Kepler moved on to the second phase of its lifetime, K2, where it started to observe different fields, and now we have the TESS satellite, the Transiting Exoplanet Surveyor satellite, still the original Kepler mission is where we still have the best exoplanet data from, because it was just one field that Kepler really hammered year after year. So it's the most complete data set that we have, and statistically speaking, we know the most about it. So if you're going to make a really robust model of not just what did Kepler see, but do we really know what Kepler wasn't able to see? That's, once again, from a statistics standpoint, that's what made Kepler so useful. We can really build a theoretical model, a theoretical framework, and try to get the best understanding of what was out there, and then extrapolate that out into the galaxy. And that's what Kepler did. Here, we have one of the really cool orreries that Kepler published. Is this coming through for everybody? Did I have the bandwidth for that?
Yes, you do.
Good.
Well, good. All right.
Good.
I was hoping so. So this was the fifth one. I didn't see anything newer than this that was published, or maybe it was just from the original Kepler data. But I always love these, the Kepler orreries that they published. Hopefully people have seen these before. They published a few of these, just showing all the different planetary systems that Kepler was able to find, and the different orbits that they have, and the relative sizes, and based on the distance of this planet from its star, what rough equilibrium temperature the surface of the planet would have. So just a quick visualization of some of the planetary systems Kepler was able to find during its lifetime. Bottom line, as this slide and the next one, Kepler has found a whole bunch of planets. So we were able to get really great statistics. And in fact, just last year and this year, just I think it was February. I think it was February of this year. Some scientists, I think a grad student and a couple astronomers at Penn State. The grad student was Sue, and they published a couple different papers in the Astronomical Journal and maybe the Astrophysical Journal. And they gave their numbers on data release 25 from the, I've got a question here from the chat. Let's see here. Let me pause real quick. A question for Dr. Engel. Big galaxies get big by eating little galaxies. Could this seed the core of the galaxy or globular clusters with heavier elements needed for planets with the materials needed for life? The answer is yes. There you go. Yeah. So galactic mergers, things like that, they could definitely help seed metals into the galaxy. They definitely could. It would also certainly wouldn't help with some of those gravitational interactions, though, but that would impact all throughout the galaxy then. It would make the entire realm chaotic, but eventually things would start to migrate down into that core. So the core would become an especially chaotic place. So it would be a double-edged sword. Let me see here. There we go. All right. So back to the slide. So the Sue et al. Last year and this year, they studied F, G, K, and then M stars. So these are generally seen as the most favorable stellar targets now for life. More massive than this, O, B, and A type stars, very hot stars. Planet has to be very far away from the star. So just in terms of warmth, sure, as long as your planet's far enough away, it could manage to cool itself down. The issue is that they live very, very short lifetimes. So in terms of an O star, where you're talking about maybe living 1 million years, something like that, in terms of the picture of how life evolved here on Earth, it wouldn't even be long enough for life to take hold. It might not even be long enough for the planet itself to cool down. It might not be long enough for the planet to form. O stars are out of the picture. B and A stars, so again, they're massive enough that they burn through their fuel very quickly. They still have short enough lifetimes that if life has a chance to even start, it would be so primitive by the time the star itself is getting ready to end its life that they're simply not favorable targets. So ordinarily, when we talk about now the stellar targets, we start at F-type stars. Still hotter than the sun, still shorter lifetimes, but theoretically possible that you could have life take hold and still have time to evolve. Perhaps not to the point of intelligence, but again, that is putting everything, in the case of assuming that Earth was the standard and it would take life elsewhere as long as it took us here. So FG and K dwarfs, they published in 2019, and they determined that there would be on average 3.5 planets for every single FG and K dwarf in the galaxy. For M dwarfs, there would be 4.8 planets for every single M dwarf. F, G, K, and M dwarfs now, you're talking about 96, 97% of all stars in the universe. So, statistically speaking, there's going to be a lot of planets in the galaxy if the statistics hold up correctly. So again, this is based on an observation of 100,000 stars out of a galaxy of a few hundred billion. But it is based on the best data set that we have, the most complete data set that we have, and our best understanding of the instrument itself that observed, that took that data. Now, this is just planets. How many planets per star? Solar system, depending on your exact take, it either has 8 or 9 planets, and that'll open up an entirely new debate as well. But it's not just how many planets a star has. We're interested in the habitable planets. I'm sure you've seen illustrations like this many times before. Now you bring into account not the habitable zone of the galaxy, but the habitable zones of the stars themselves. Those F stars that we talked about, they'll have pretty large habitable zones. The habitable zones get closer to the star, the cooler it gets, because you need to get closer to the star to keep that warmth. And they also get narrower and narrower the closer they get to the star. So once again, it becomes a numbers game. There's more and more K and M type stars out there, but the habitable zone gets narrower and narrower, and it gets closer and closer to the star as they get smaller and smaller. So it's all about this real estate game that we're playing. But taking this into account, those same studies down in the lower left here found in their most, the strictest, the most conservative estimates, a 0.38 habitable zone, Earth-like planets per M dwarf. And here they're talking about, radii, so planetary radius, 0.75 to 1.5 times the radius of the Earth. See another chat here. Do these numbers take into account moons of gas giants? Ah, yes, exactly. I had a note for myself written down actually to bring that up. So good. I'm glad you brought that up. No, this does not. So the issue here, it's another theoretical out there that we would have a very hard time, getting a grip on that. I mean, Jupiter and Saturn. I don't even remember the most recent number for their moons. Each one of them is somewhere around 80 moons. I think Saturn just overtook Jupiter or something like that in terms of number of moons. But yes, this actually leaves out the fact that you could have a gas giant within the habitable zone of one of these stars, and it could have a habitable exomoon around that. That is, I don't want to call it an X factor, but that is a very hard variable to actually calculate. If we're talking about that, yes, every gas giant could have 80 moons around it, and perhaps one, like in the case of Europa or something like that, or perhaps you're talking about, Ganymede, Europa, the Galileans, they all have some form of ice, perhaps not Io, but 3 of the 4 of them have ice on them, so they could be habitable in some form or another. It's the statistics of exomoons really start to become tricky. It's an excellent question, but no, this does not take that into account. This is strictly planets because it's what we have the best sense of in terms of the numbers. But thank you. That's a good question. So keeping it to the planets and giving it their most conservative estimates. So 0.38, 0.4, we'll just say, habitable zone and Earth-like planets per M dwarf. Like I said, 0.75 to 1.5 times the radius of the Earth. Getting to the FGK dwarfs, they could not get a strict number. As we said, it occurs, the planetary occurrence rate is less often than for the M dwarfs, so less than 0.27. When they gave it a slightly larger radius range, then it was 0.17. Habitable zone planets now in that super Earth range, but the lower end of super Earth, so 1 Earth radius up to 1.75 Earth radii. So a little bit larger than the Earth, but still well within what we believe theoretically would still be a terrestrial super Earth sized planet. No, good statistics once again. So the number of habitable planets we have an okay idea on, and this is just what you would call, bulk observables or first order observables. This leaves out the very tricky issue of the planets themselves and just what conditions are like on the ground. What is the atmosphere made of? We don't have the technology yet to really tell us what the atmospheres are made of. We've managed to get a few observations telling us that there are some trace elements within gas giants that are transiting certain stars, things like that. We haven't gotten close to measuring anything that we would think is a terrestrial planet. We're hoping that James Webb, when it eventually launches, that's what it's going to hopefully do for us after it's gathered data for at least 3 years or something like that. Hopefully it'll be able to give us maybe a biosignature or two. So this ignores, any sort of atmospheric signatures from the planets, things like that. This is just based on size of the planet. If you can get radial velocities and tell us what the mass of the planet is, use the average density, hopefully you can figure out that, yes, this should be terrestrial. Maybe there's some water there, something like that. But again, it's up for debate. Then you have the other debate that if it's larger than the Earth, how much larger is it? If it's a super Earth planet, what are plate tectonics like on a super Earth planet? Is convective motion inside the mantle, can it actually happen? Can it have a magnetic field? Or is there so much mass on top of it that it's actually keeping everything down? It's preventing a magnetic field from being generated. If it doesn't have a magnetic field around it, even though it's a super Earth, it's not going to have enough gravity to hold on to its atmosphere, is it? It's still going to get stripped away by a star. There's so many questions around strict planetary habitability that we're just not there yet. It's all models, and it's up for debate. There's still a lot that's up for debate when it comes to the planetary properties themselves. So we stick to what we can observe, and we've put together some theoretical models that can tell us, yes, it could be rock, it could be iron, it could be water, but there's a lot of uncertainty there. And this is the most certain of the parameters in the equation. Now we move on. Next, we get to that F life. Abandon all statistics. Ye who enter here, we've now left the certain part of the equation. I said the number of habitable planets out there, that was what we had. That was what we've devoted a lot of our resources to, and we've got actual numbers involved beyond Earth. After that, we can tell you what we've experienced here on this planet, and we can tell you what implications there are and what it could mean for extrapolating it elsewhere. But after that, there are implications. But there is a great deal of interesting information there, and you can guide your discussions. So yes, any questions that you want to bring up at this point? Like I said, always, my ears are open. So, all we know is that life happened here. The question is, can it actually happen elsewhere? It was primitive life that first started off. We're talking about bacterial life that first took hold here, and it took hold in the very beginning. What we want to see is, how can we take our story that we're telling ourselves about how it started in the beginning on Earth and all these different stages that life went through to go from the simplest, most humble beginnings, getting us to where we are now. can we extrapolate this one data point, this one time frame that we have, and can it tell us anything about the odds of finding it out elsewhere? If you're trying to figure out F sub life, the fraction of these planets where life would take hold, what you really want to know is, yes, it happened here, but what's the likelihood, of course, that it would happen elsewhere? So basically, you know, how robust could life be? You know, how strong would life be, and what could it really handle? What could it have thrown at it, and what could it still really survive? So that's going to be the big question. What have we been able to tell ourselves from this? Well, let's go through the beginnings. You know, what do we know about the earliest beginnings of life? Well, it depends on what you mean by that. Pictured here are stromatolites. They're the earliest, more or less, agreed upon fossilized evidence of life. They go back about 3.4 to 3.5 billion years ago. Those are the oldest surviving stromatolites. What stromatolites are what you call microbial mats. Basically, colonies of bacteria are spread out on either shallow seas or something like that, little ponds. And what they did was they either took, you know, limestone, whatever sediment was in the water, whatever waste was left behind from their metabolisms, things like that. They deposited it down on the ground beneath them, and then they would move on top of that, and the next colony would rise up, and it would live out its lifetime, do its thing, deposit down whatever was in the environment around it, move on top of that, and so they would build up these stromatolites over time, these mushroom-shaped blooms, and they would kind of leave them behind as the fossilized remains. And it has little telltale shapes, these swirls and things that would show you the colonies of the microbes that kind of lived out their lives these billions of years ago. So the oldest, mostly, there's still some debate, but for the most part, agreed upon, the oldest fossilized evidence of life. So most scientists agree that life had already taken hold by, let's just round off and say 3.5 billion years ago in the Earth's history. That's a very long time ago. Now, life has to actually predate this if it's already leaving behind fossils. Even though stromatolites are simple bacteria, our point, if they're advanced enough to have left behind fossilized evidence, there must have been something even simpler that had predated them. So there, 3.5 billion years ago, life must be older than them, must have even humbler beginnings that did not leave behind any sort of surviving fossils. So we know it's older than them, which is interesting. Exactly how much older than them? Well, you have to get a little bit more inventive. And there's going to be a time where you're just not going to find anything. Because as you really start to go back, you enter the Hadean eon of the Earth, what we call the hellish Earth. When at first the Earth was cooling down, there was the bombardment period of the Earth, even the late bombardment period of the Earth, which ended right around 4 billion years ago, something like that. Even that's now debated within science as to whether or not the late bombardment even happened. Everything's debated now. But this was a point when the Earth was vastly different. I mean, really, really different. It ended around 4 billion years ago or so. It was very difficult for anything at this point to have left behind fossilized remains, just because of how different the environment was. Intense volcanic activity, formation of the moon happened at this point. If you believe that it was caused by a massive impact that formed up the moon, which many scientists do believe, although it's debated, then there was a great deal of activity, great deal of chaotic activity. There was the oceans themselves were even acidic, although we believe that the oceans themselves formed around 4.3 billion years ago, because the massive impacts that formed up the moon and from the bombardment period probably sent up a lot of volatiles up into the atmosphere. So that atmosphere probably about 27 bars or so, about instead of 1 bar. So even though the Earth itself was incredibly hot, water that was present was able to stay liquid at such high temperatures because of the high atmospheric pressure that was around at that time. So it was a very, very different planet, is what I'm trying to say, 4 billion plus years ago. Why it's called the Hadean, why it's called the hellish Earth. We do have evidence, though, that life actually started at the very end of the Hadean eon. We don't have fossils from this period, but there are actually a number of studies all indicating that perhaps life began around 4.1 billion years ago. The study from 2004, at this point, like I said, you have to get a little bit inventive when you don't have fossilized evidence. Most of these studies use a form of genomic sequencing and genomic dating, also called molecular clocks, where they study the genetic relations of primitive life forms and bacteria, things like this. And they study how long it would take for some of these mutations to have taken place. And they try to wind back the clock to see when all of their ancestors would have come online, basically, and how long it would have taken for mutations to have happened. And they try to basically see when the most primitive life forms would have taken hold using this method. And several of them agree that then the origin of life would have been around 4 to 4.1 billion years ago, just the very end of the Hadean period. So here we have the plot from this 2004 study. And you see at the bottom here, the origin of life itself, 4.1. The error bar takes it right back to the very origin of the Earth itself, around 4.5 billion years ago. Then it goes through some of the vastly different, atmospheric and terrestrial, conditions that life itself has gone through. So you talk about the robustness of life and, the different conditions it has thrived under. And shortly after life took hold, as I said, the atmosphere was incredibly different. The atmosphere had a couple thousand times the concentration of methane in the beginning that we have here. And there was no free oxygen around. So in the beginning, you have this methanogenesis, methanogens, basically different bacteria come online that what they actually breathe in and what they actually generate out is methane gas. So methane was always, it was all the rage, if you will, back then. You have anoxygenic photosynthesis. As they started to move closer to the surface and started to try to use up sunlight, at the time, the UV concentrations on the surface of the Earth were some around 400 times the concentrations that they are now. So it took a while there. It took over 1 billion years or so for life to eventually evolve and mutate to have certain types of pigments available to protect themselves from some of the ultraviolet radiation that was around. But eventually, anoxygenic, because once again, there's still no oxygen around, or at least very, very tiny concentrations of it around. Eventually, they start to move their way onto land. Right around this time is when the great oxidation event happened. Cyanobacteria primarily, things like stromatolites and whatnot. Some of the earliest cyanobacteria around, they started pumping out great deals of oxygen into the atmosphere. Oxygen is a very good job of carrying out metabolic processes. It allows organisms to become more complex. So they're able to get onto land, they're able to carry out more pigments, protect themselves better from the more dangerous circumstances they would find on land. So that's when aerobic processes can come online, and oxygenic photosynthesis, oxygen becomes involved in more processes. Organisms become more complex, things like this. But this one figure, it shows you again how robust life can be from its simple beginnings, but vastly different beginnings than what we have now. So again, talking about a potentially habitable planet, it's easy to get tricked up and think, when we talk about habitable as far as we're concerned. When we're talking about life out there in the universe, life here on Earth started in incredibly different circumstances than we have now. But there's still evidence that shows that it started only 400 million years or so after the formation of the planet, when it was incredibly different. I see another chat coming in. Let me see. Call up the screen here. Oh, it's not calling up the chat screen for some reason. Oh, there it comes. Good. So I guess my question is, when you say life, are you talking about one event that evolved into us, or the winner of multiple events? I would think that would have a major impact on a number of planets that could support life. It's about one event that evolved into us, or the winner of multiple events. Well, you're talking about life elsewhere. when you're talking about a habitable planet or you're talking about life on a planet, if you're talking about the Drake equation, we're usually talking about communicative civilizations. So you're talking about anything that's sending out signals or is receiving a signal. When you're talking about a habitable planet, the conditions can be varied. And we're talking about under what conditions life can take hold. Figures like this show us that life can start under vastly different situation than we have right now. And in fact, on Earth, it started under a very different situation. So we are the result of a long chain of events. And we, the common ancestor, if the theory is correct, that everything on a tree of life was incredibly different than we are now. So if we were to look at the Earth 3.5 billion and 4 billion years ago, there'd be no way to predict, what we would look like now based on that. So that's all of the uncertainty that goes into these factors. So here, the results of this plot of 2004 study. Here is another study as well, 2001, using the same overall method, these molecular clocks, but using a different data set. And again, an overall study that agrees from the top plot here. They were interested in this origin of the Earth and then this error bar right at the very top, right underneath the hedges et al. You can see that roughly 4.1 billion years or so, talking about where the eukaryotes and the eubacteria had split off to each other, that origin of life. That's 2001. And then one last, just from 2015 itself, 4.1 billion year old zircon crystal. And the fact that the zircon crystal had not been cracked at all, it was preserved, as it says, very well preserved crystal. Zircon crystals are almost indestructible, as it turns out. They'll survive long amounts of time, 4.1 billion years old in this case. And they had found carbon isotopes, ratio of carbon 12 to 13, that has, under normal circumstances, likely, biogenic origin. It is possible that it also has a natural geological origin. I said, in most circumstances, depending on, ordinary situations, biomes, if you will, would produce this type of carbon ratios. Going back 4.1 billion years, it's impossible to know exactly how this ratio is produced within this zircon crystal, but it was preserved for the team to find, and it's a tantalizing bit of evidence. Once again, it's perhaps direct evidence that an actual biosphere had been set up on the Earth by 4.1 billion years, not just theoretical studies using molecular clocks like the previous results I had given, but some sort of actual evidence that had been preserved inside this crystal for us to find. I see another, oops. Let me see here, chat. So, do we really need the habitable zone to factor into the possibility that life could exist if Earth was such a hellhole when life started here? That's the next interesting question. Now, that brings up evolution and what life can tolerate over time. We currently enjoy the habitable zone. And we, if you were to transplant the Earth outside of it, we would not be able to tolerate that, not without some very, very, advanced warning and some good technology, to the rescue. If Earth, let's say the Earth had been just a little bit closer to the sun and life took hold under what were habitable conditions at the time, and the habitable zone moved past us, could evolution have handled that type of a stressor? I do not know. It's interesting. Life has handled so many things. I mean, the blue-green algae and things like that. There was an entire biosphere on Earth that was anaerobic, and it pumped out so much oxygen that it killed itself off during the Great Oxidation Event. So, but but obviously it did not destroy the biosphere. It just made a new one, and life handled that. New life arose. So there have been mass extinctions. It's this is why I find some of these parameters so interesting, that life has been able to handle a lot of things that have been thrown at it. And so we think of these parameters within our own modern context. We put so many things in our own context, but looking at the history of life and all of the different twists and turns that it's taken, life's been through a lot, and it's taken a lot. So just knowing what to look for out there, we look for our most narrow definition of life, because first of all, we want the easiest answer. We want somebody who's on the telephone saying hello, because that would be the greatest thing, for someone like SETI to find. But it seems like there's all sorts of possibilities out there, just in terms of potentially habitable planets. So there are questions out there about the conservative habitable zone versus the extended habitable zone, just in that realm itself. So perhaps the habitable zone itself needs to be reevaluated. But like I said, we keep it local to ourselves. We keep it in our own close context. There's a reason I find these things so interesting. So a lot of our information on this parameter now implies that for most, 80% or so of the Earth's history, 90% plus, sorry, even back when it was, by all logic, uninhabitable, that's when life started, and it stayed, persisted for 4 billion years or so, at least 3.5, likely 4 billion years, continually changing, continually evolving, eventually making its way to us. So it seems that life is robust. That would imply that F sub life could be pretty high, could even be close to 1. That if you have a planet that could be anywhere near habitable, perhaps it's just a matter of time before life takes hold. And once life takes hold, it's not going anywhere. It'll figure out ways. Now, whether it's simply bacterial life or something like that, well, that involves the following parameters. Just what life does once it's there. Whether it simply survives, whether it thrives in number, or whether it thrives in complexity and grows in complexity. Well, that involves the following parameters. So the next one, F sub civ. How do you arrive at civilization? And of course, everyone, always, depending on if you're there by yourself or you're with somebody, you can you make all your jokes and things like that about whether or not we actually have one, and if we ever have had one. That's if you're talking about a communicative civilization, one that's trying to communicate with other worlds, things like that, you at least need to get to civilization, if not advanced technological civilization. So it's not just enough to get life on a world. You're not just talking about bacteria, things like that. You want them to evolve essentially some form of intelligence. And again, insert jokes there, Let's go to some of the big milestones, if you will, on our own planet. We know of, once again, one data point. That's it. Talking about here on the Earth. Talking about an advanced technological society or civilization. There's one species that has done it here. It's humans. In the broader context, mammals have done it. That's us. Going way back. So Earth forms 4.54, but was 4.5 billion years ago, rounding things off. Making it simple, we'll simply say that life emerged around 4 billion years ago. So 500,000 years after that, life emerged. Happened fairly rapidly. Pretty cool. We are complex life forms, so we are eukaryotes. We have a nucleus inside our cells. We're not prokaryotes, so we have nucleus inside of our cells, carry genetic information, yada, yada. Eukaryote fossils, they first came online around 2.1 billion years. So once again, if they left behind fossils, they're probably a little bit older than that, but those are the oldest fossils that we found so far. So 2.1 billion years ago is when eukaryotes come online. Animals, 590 million years ago. Synapsids. This is where these are basically, proto-mammals, if you will. Synapsids are just as we are now branching off from reptiles. So our last common ancestor, mammals and reptiles, would then go their own ways. So 308 million years ago. Mammals, then official mammals now, not these proto-mammals, these synapsids. Mammals themselves is their own distinct group. 220 million years ago, just before a time or so, we get into the age of the dinosaurs then. Mammals get pushed down into their own, very narrow little niche for this amount of time. And that's obviously its own intensely debated realm. What exactly was going on during the age of the dinosaurs? What would have happened by that point? So we are all descended from these synapsids. The sauropsids that went on to become reptiles, eventually become birds, crocodiles, the dinosaurs, lizards, things like that, turtles. That's when we diverged from them. They had their age. Mammals were pushed down into these small little niches for all of that time. You don't hear too much from us by that point. We're evolving continually all throughout that, as the reptiles themselves are as well. Jump ahead all throughout that point. Next big thing, around 6, it's 4 to 8 or so million years ago. So we have the human-chimpanzee divergence. Humans and chimpanzees split ways. Obviously, we're not humans by that point, but what would eventually go on to become humans. And chimpanzees diverge from each other on the evolutionary path. The genus, the Homo habilis, Homo erectus, Homo sapiens eventually come online 2 million years ago. Homo sapiens, 300,000 years ago. What we would then consider, we call fully modern behavior. Fully modern behavior in this case is things like various forms of art, things like that. That's what we would consider fully modern. So we call self-ornamentation, music, various forms of burial rites, trade amongst different human groups. That's what we consider modern behavior. So we consider that to be an essentially modern equivalent of our current form of intelligence then, roughly speaking, in evolutionary terms. That happened roughly 30,000 years ago. So how long it took, for the earliest life forms to evolve to get to essentially modern level of human intelligence, just based on our behavior, our behavioral traits. And like I said, it's just gross behaviors like burial rites, trade, art, some of the more abstractions that we've come up with that indicate higher level cognition. 30,000 years ago, around 0.00075% of life's time here on Earth has been what we would call, intelligent. So it took a while. It was a long evolutionary path to get from the beginnings of life to intelligence. So is that the norm? And the fact that we are the, once again, I know there will be all sorts of jokes that are made, the fact that we are the most advanced intelligence in terms of species on this planet. We seem to have, if you will, done it the quickest. Once hominids split off from chimpanzees, chimpanzees are pretty intelligent too. All the primates, all the great apes, they are fairly intelligent also. Once we split off, the genus Homo really started to take off in its intelligence based on just not like in our behaviors, developing burial rights and trade and things like that, but actual physiological, anatomical evidence that we have on our evolutionary pathways. We seem to devote a lot of our resources into our brains compared to other primates. I see something else coming in on the chat here. It takes me forever for some reason to call up the chat window. Let me see. There it comes. Ah, good. Oh, good. So we have someone who works in the field. Perfect. Fully modern behavior predated 30,000 kiloyears. Yes, I'm trying to be conservative about and say that we know for a fact that by 30,000 years ago, if I had seen estimates, I saw one about 46,000. I saw one going up to 60,000. I don't know what the oldest is, but I know for a fact that by 30,000, it was what I would call fully modern behavior. But yes, I did see a range of ages on that too. So yes, so fully modern behavior predated 30,000 if we look outside of Europe. But your point about how long it took to get to the hominin ape split is well taken. Oh, good, thank you. So yes, good comment. So yes, so by 30,000 years ago, we know that we have this fully modern behavior online. We're talking about getting ourselves to the point of our modern intelligence. Now, the biggest thing that, well, you can also weigh in on this in the chat too. We talk about oxygen and its availability. And can you involve other chemicals? Can you involve other elements in it? Brains are very oxygen hungry, especially neurons. Neurons involve oxygen in their metabolism. You need a lot of resources if you're going to devote yourself to growing a large brain. Humans seem to have done that. The genus Homo seems to have done that, especially compared to its closest relatives. So you could make the argument that we've done it faster than others. And it still took a while. Is that normal? Is there anyone else who could do it? That's what we really want to know here. Yes, we're around. How do we compare, though? How do we really stack up to others around the planet? That's what the Drake equation is about, and that's what we're trying to figure out here. So getting outside of ourselves, which is, again, incredibly difficult to do. But if you're trying to figure out not just human intelligence, but even just going through our own ancestors and just trying to get into other species now, you try to find some sort of objective way to do it and not keep on anthropomorphizing it or not just humanizing it, and like that. So we look for biological indications of it. One of the ways you can do it, which is debated as to just how useful it is, but it's what we have available. One of the things you can do is you can come up with a ratio of size of the brain to the size of the body. So you can at least have a look at what resources the organism seems to have been devoting towards its brain versus, once again, its overall body mass. Now, this will also ignore things like the density of neurons, types of neurons, folds of the brains, things like that, the various centers, and it ignores structure itself, specialization, but you have to start somewhere. Once again, trying to compare everything that we've been able to put together. We have the reptiles, seem to form up a pretty nice linear relationship. Talked about, dinosaurs were on this earth for a while there. They occupied the top of the food chain for a long time. They didn't build cities in those millions of years that it was their age. And bring up mammals. Mammals across the board seem to have larger brains for body size than reptiles do. A few ones of note: dolphins, widely regarded as socially complex, highly intelligent amongst the mammals. Whales, again. Oh, actually, I mixed them up. Sorry. Elephants and then whales are supposed to be elephants on the left, whales on the right. So 3 outside of humans, fairly socially complex and intelligent examples of mammals. primates, which generally as a class exist along the high edge of this, brain mass to body mass ratio. And of course, where the humans roughly weigh in as well. Generally above the trend. As I said, we seem to have devoted a great deal of resources to our brains. So what does this imply then? Is it only the mammals that could have evolved intelligence? We came from common ancestors, and we split a while ago. What does this imply for getting outside of the Earth? If we have done it, are there going to be other mammals then that could do it behind us? Is human intelligence stagnating? Well, there are debates about that too. Something called the Flynn effect, where they've noticed that IQ tests every generation or so increase by about 7 or 10 IQ points. That's another joke that's just waiting to be made, depending on your thoughts on the future generations, especially millennials coming online, things like that. But the Flynn effect is something that has been noticed, for a few decades now, and that is also debated as to whether or not it's simply as technology around us has evolved, things like TV and video games, and as children have learned that they need to process information faster, has the type of intelligence simply changed over time. So even human intelligence now is getting harder to compare within humans of different ages. So it's hard to compare intelligence at all. But moving outside of just us, we do have evidence of changes within other mammals too. Here, we go the bowhead whale and the blue whale. Blue line, it's body mass. Red line, it's brain mass. Going over the past 50 million years, right? And at the bottom line of the green line, we call the encephalization quotient. It takes the ratio of brain mass to body mass, and it uses this one factor here, this normalization factor, which tries to take into account just how the head of the animal is arranged. So it tries to take into account the fact that humans have this well-designed head here, but not every organism has a nice, essentially detached head that really centralizes where their brain is. So it tries to take into account how they are built and how their brain should be kind of structured, if you will. So that comes up with this EQ, this encephalization quotient. The bowhead whale, the bluehead whale, its EQ has stayed roughly the same over the past 50 million years. Same thing for these two different types of sperm whales. There's perhaps a little bit of an increase over time, but no, for the most part, it is leveled off. Common bottlenose dolphin, which is one of these species that you hear a lot of stories of, just how, once again, socially complex, how intelligent they are, their encephalization quotient has been rising up a good bit over time. Same thing with the Indo-Pacific finless porpoise, another species there. Encephalization quotient has been on the rise for the past 50 million years. So within other species, there is potential evidence. Now, we don't know. This is just from fossilized evidence and brain scans and things like that, or brain pans. We don't know how they were behaving 50 million years ago. We can't give them intelligence tests back then. These are just, fossilized biological tests. It is an indication of potential growth of intelligence in other species alongside, what we know our own ancestors were experiencing. So perhaps humans are not the only ones who were on this path where they realized that intelligence was worth the resources. So does this give us hope that, again, intelligence is not necessarily a fluke, that other episodes of convergent evolution, people will realize that intelligence has survival value. Dolphins are doing it, porpoises are doing it, elephants, they show some socially complex behaviors, they have memories, things like this. The issue here, though, talked about reptiles versus mammals. What happens if you want to get beyond us entirely? Are mammals the only game in town? Is there any other group entirely? Do we want to see, can we broaden ourselves at all, broaden this understanding? let's see the chat. I'll put, how is culture taken into account? Intelligence alone does not imply communications. Yes, well, culture, we try to go with what we have. The culture would come into account when you're talking about whether or not they would like to communicate with anyone else. You know, we're simply trying to get into the issue of evolution at this point. You know, the emergence of intelligence itself. What they do with that intelligence, do they decide to devote it to, you know, the building of technology? Do they decide to devote it to art and culture, and they don't care about searching for extraterrestrial intelligence or anything like that? It's, you know, do they decide to devote it all to military resources and they fight with each other constantly? And again, they never look up at the stars. At this point, we're simply trying to get some sort of statistics about what life has done here and what we think they might do elsewhere. There isn't one here. Another one. Dr. Engel, isn't one thing missing here is the presence of a protector in the planetary system that minimizes asteroid strikes. I mean, look what happened to the dinosaurs. I would think it'd be very unlikely for man to develop if Jupiter wasn't catching stuff from the Oort cloud. So if you had an Earth-like planet without a Jupiter, is it reasonable to assume that intelligent life would not develop? Well, we have a couple of these different X factors too. We have Jupiter. We have like a shepherding gas giant, if you will. There's also the other issue of a large stabilizing moon, which is what Earth has. It's unique among the terrestrial planets. The fact that without the moon, our rotational axis would tip wildly, kind of like Mars does. It would make it much harder for us to have sustained agriculture. Much harder for us to, you know, it would be harder for us to develop that sort of sedimentary culture. And to what type of impact would that have had on our development? Again, it's much harder to put that into a statistic. If you wanted to simply say not the fraction of planets around stars, but the fraction of nearby terrestrial planets with further out large gas giants to protect them, that's, you know, it would just be much more difficult to quantify that. And also, it's coming off of a single data point. We have Jupiter and we have massive impacts and the extinction level events. Without Jupiter, how many more would we have had? I'm not personally sure. I wonder if anyone has done models of that. But yeah, I mean, yeah, there are without a doubt different factors that could go into it, exactly what makes a planet habitable. So we concentrate on the observables that we can get an idea of. And because it's a statistics game, we hope that you could have either, you know, there's the TRAPPIST system where there's 7 terrestrial planets, like 7 super Earths. Depending on just how massive a super Earth is, if you've got 7 of them, perhaps they could shield each other. If one of them is habitable and the other 6 aren't, perhaps the other 6 could swallow up enough debris. They aren't Jupiters, but if there's that many of them and orbiting a small enough star and they're in tight orbits, TRAPPIST isn't habitable for a number of reasons because it's such an ultra low mass star. But are there other situations where you could have shielding bodies without a Jupiter? Perhaps. But yeah, there are other factors here that are going to be much more difficult to quantify that couldn't go into it. The Drake equation has always been, at its core, an oversimplification. But it gets the conversation started. And that's what makes it great. It does bring up these extra questions, these extra, you know, not quite observables, but topics that you do need to take into consideration. Oh, yeah. So, can we get outside of mammals now? Is there any hope? And hopefully there is, as it turns out. The question becomes, what about birds? They probably the next likely candidates. Going back to the plot that we had, the reptiles, the mammals, the primates, humans, yada, yada. Birds, in terms of their brain weight to body weight, overlay the mammals with some different species within some of the different breeds existing right at the top of the mammal ratio as well. Some crows are incredibly intelligent, African gray parrots, things like this. Some of them are very, very, at least based on the different characteristics, the different behaviors that we have come to understand, once again, based on what we know of ourselves and how we define intelligence. And primarily, we look for either social behaviors or things like that. We observe certain breeds of bird to be rather intelligent, rather highly cognitive, if you will. Well, let's get into some of the things that we see. We talk about bird intelligence. They said higher order consciousness from birds. First, several breeds observe and display an advanced social hierarchy, where certain birds will actually place themselves within a hierarchy simply by observing social cues from other birds. So this ability to observe other members of their species and pick up on almost an empathy for others, and also, as I said, that picking up of social cues. So whenever we see social behaviors from other species, we tend to, with our human understanding, we tend to assign a type of intelligence and a type of higher consciousness to that. There are several different breeds of birds that show these advanced social hierarchies. Also, on average, as we showed in the plot, birds which did evolve from a common ancestor with reptiles, they only split from the reptiles after the age of the dinosaurs. They have brain to body masses on average or so 6 to 10 times, almost an order of magnitude higher than the reptiles. So again, like when we had split from chimpanzees, just very recent in evolution, after the birds split off from the reptiles, they seem to devote more of their resources into their brains than the reptiles did. So they also seem to have an evolution that favors brain mass. Object permanence is another trait that the birds seem to show. Object permanence and what we call an episodic memory. A few breeds seem to show an anticipation. They would remember what times of day they would receive things like treats, objects like that, objects that they really wanted, desired. There was actually some parrots that actually showed signs of surprise, frustration, and even anger when either the behaviors that they had come to expect were broken, or if a different object was actually substituted for the one that they had expected to receive on the day. So it was something that we had come to expect as an intelligent behavior. Not necessarily the anger part, but still impressive nonetheless. Birds, as we know, if you ever have one as a pet or if you just hear them out in the wild, advanced auditory and vocal skills. Not just mimicking human speech or anything like that, but in the ways that they communicate with each other, and also in the ways that they could be trained then to understand some of the languages that they pick up. And in fact, the African gray parrot, under laboratory conditions, there was papers that were published that African gray parrot was able to show an understanding of numbers up until the number 7. It was actually able to show an understanding of numerical number, the actual number of objects. And tool manipulation. A few different breeds. Crows are one. I forget. Is the corcoran, I believe. Oh, now I forget the specific name of the breed itself. There's a few different breeds of bird that have actually been observed in the wild to use various tools, sticks like that, to either get at insects within logs, what have you. One within a laboratory setting, I actually forget, I think it's a cormoran. I think it's a breed of cormoran that in a lab is actually raised from a chick. So it did not have interactions with the wild. It wasn't taught this at all. Used a wire and bent the wire and actually use this wire as a tool to pull a small bucket of food up through a tube in the lab under laboratory conditions. So the birds have actually shown somewhat sophisticated tool manipulation, which once again, we associate with pretty high order intelligence, puts them on, in order, according to the study, this level of tool manipulation puts them easily at the level of primate intelligence based on that level of tool use. So birds would seem to be an excellent example of good odds, if you will, that it wasn't just mammals and not just humans, things like that. There are other entire groups that seem to also be valuing intelligence. So again, it doesn't give us a hard number, but it gives you some hope that if life takes hold, intelligence can be, if not likely, at least possible. That brings us to the last variable that we have, F sub now. What I have here, does the past inform the present? This one we know the least about. Highly theoretical. If civilization comes online, we have intelligence, how long will one last? There have been a few different studies that have been carried out for this. Because we don't know how long into the future we're going to be around, it had to go into historical civilizations. Now, historical empires, a few published studies have said that it lasts on average somewhere around 400 years. After the fall of Rome, modern empires seem to actually last for a somewhat shorter amount of time, about 300 years or so. Again, it's heavily debated. The big question that was raised was exactly how a modern level of technology would then influence this. Obviously, the prevalence of weaponry and the proliferation of weaponry that's a real X factor that is involved. But also, when technology really starts to come online, does that in fact lengthen not just any individual empire, but does that lengthen the collective memory of a species? Once you discover a computer, something like that, once you discover cloud computing, or at least cloud memory, something, is it possible to ever really forget what a species has learned? Once you start broadcasting it out there into space, things like this, it brings up the possibility that, once you get artificial intelligence online, anything like that, will a species become immortal, not in the biological sense, but will its knowledge persist in some way, shape, or form? If America as a country falls, is our knowledge simply going to be remembered by Canada, Mexico, France, anything like that? No one's going to simply forget the things that we've learned. So how exactly does technology and modern technology influence that now that we are past the fall of Rome and things like that, where once you burn the Great Library of Alexandria, it's gone for good, unless you have also gone through and magnetized everybody's hard drives and yada yada, that data still exists. So the collective knowledge of a species is now in digital form and exists in multiple locations. So barring a massive cataclysm, do you need the empire to survive, or do you simply need the knowledge to survive, and somebody will just pick it up and learn and continue on? So this is a massively uncertain variable, and it's all over the place. And then it also brings up the question that we had before: do you even need, if you're talking about extraterrestrials, do you even need them to be alive anymore if you just want to answer the question of is life out there? If you don't need back and forth communication, do you just want to receive a signal that was of intelligent origin? And that's that. So, in conclusion, the equation starts out all right. The number of habitable planets, we still had those X factors, and there's still the debate about a galactic habitable zone, and whether you have a stellar habitable zone. So life started off with methane, acidic oceans and things like this. So it starts off with less uncertainty, and then it goes off the rails quickly in terms of a solid answer. But but I love all the areas that it goes to. And there's a whole bunch of information there that I think is just fascinating. So I hope everybody else thought it was fascinating too. And obviously, if anybody has any other questions here or comments, let's have at them. I guess at this point, do I stop sharing the screen and go back to video? What do we do?
Yeah, why don't you do that? We can turn our cameras back on and.
All right, let's see here. So yeah, so thank you for having me, and let's see if we have any extra questions. Sorry if that went over time. I don't know exactly how long it was.
It was perfect.
Scott, never apologize for going over time. We love hearing you talk.
That was great, Scott. That was
very
really great.
Dark we are.
Yeah.
So are you going to give us a numerical answer for what you feel is the Drake equation if you just plugged in some numbers that you think are realistic?
Nope.
So, Scott, I have a question. How do you factor in what we know about life now that until that not that many years ago defied, what we thought life could really be? I mean, you have examples of extremophile organisms that can live in, extreme deserts in Antarctica and hydrothermal vents. It changed our understanding of metabolism and how organisms use energy and how they are able to, all of these, how do they survive under extremes of temperature, pressure, salinity and stuff? Does that factor into whether or not, into parts of the equation? It just changes what our understanding of what life really means.
Oh yeah. That's the thing. If the Drake equation is talking about people that are out there to talk to, that's what'll limit it. Who you can talk to. If you're talking about if life is out there, I think there's probably life on Europa. And I think there's probably life underground on Mars. And I think there's probably life in the clouds of Jupiter. And I think there's probably I think there's probably life all over the place.
It's not intelligent, communicative life.
So much, just here on Earth.
Right. Yeah.
It formed under crazy conditions.
Have there been any other serious equations put forward aside from what Drake did?
Yeah.
As an alternative to his equation, and what ones are you particularly interested in?
Yeah. Actually, it's another note that I had for myself that I forgot to mention. The other one, Sarah Seeger, who head of SETI, she has the Seeger equation that she's trying to get a lot of traction under. That's aiming to calculate how many planets are out there with observable biosignatures. So that's what, and obviously, why you're more interested in that is, like I said, with the launch of the James Webb Space Telescope. You want to calculate what the prime targets are going to be, like what the low-hanging fruit you think is going to be for planets that you think you might be able to actually get an idea of what their atmospheres are like. So that's her equation. So yeah, that's one big alternative.
Anybody else?
Is there intelligent life on Earth? That's the main question.
Yeah, exactly. Every time I went to one of those new transition slides, I was like, there's so many jokes that you can make for all of these slides. I was like, I can't even fit them on the slides. I'll just put in the parentheses there. I'll let everybody make their own jokes, Yeah.
I have another question. You had the F sub now at the end. How long do you think we've been at that state? Is it 100 years or 50 years?
I mean, for when we first started sending out signals that were leaking out into space.
Radio, right?
What year was the first signal sent out? When did our signals get powerful enough, broadcasts?
You're talking about like TV or radio?
In the radio. 30s, the late 1930s, right? With
30s?
TV. I mean,
According to the movie Contact, it was when.
Yeah, I know.
The Berlin Olympics, right?
The Olympics,
I always have that in my head too. Yeah, and I'm like, no, you gotta forget that,
Maybe it was Howdy Doody.
There you go.
Popeye.
I'm thinking it was Milton Berle.
That's great, Scott. Good. Really good.
Well, thank you.
Thank you.
That's really nice, Scott. Thank you so much.
So we peaked out around 37 participants tonight. That's pretty good.
It is good.
That would be like a record for a meeting, I think, so.
Well, I want to mention that on my screen, and your configurations are probably a little bit different, but I'm on the top, of course, because it's my computer. And then on the next line, we have Ann, B, Barb, Cecilia, and Jean. Means we have 6 women right here. And I just wanted to say yes. And there's probably some other ones in there. Janet is here and Linda. So I just noticed it was like right across the screen. There was.
You know what? You don't
I'm
see that in a lot of
appreciating
clubs, I think.
What's that?
Like DVAA as a fraction of the number of women in the club that we do. So, yeah, it's great.
Or at least that we saw at the meeting.
Yeah.
Is that what you said?
Their loss.
Yeah.
Anyway, Scott, I want to thank you again for not only volunteering to step up in a difficult circumstance, but for yet again coming back and being such an incredible friend of the Chester County Astronomical Society.
No, thank you.
Thanks very much, Scott. Thank you.
Thank
And
you.
if you're going to have any more
Thank
children,
you.
please give us advance warning.
That's
Will
right.
do, will do.
Excellent presentation.
Thank you. Thank you.
Yes,
That's
very
great.
interesting.
Great.
Thank
Thanks
you so
again.
much.
Thank you. Have a good one.
All right.
Take care.
All right. See ya.
Bye.
Bye.
Feel good? Hi, John Hepler. Where's John Hepler? Did he leave?
No, he's still there.
Hey, how's the
Sorry.
cat?
Hey, John.
The cats. Everybody's upstairs sleeping right now. We had beer earlier, and so they were excited about that. But I didn't want to disturb the presentation, so so then they got bored and went upstairs. And so they're asleep. So until I want to go to sleep, and then they'll decide they want to play.
Of course. That's a cat.
That's the cat. Yeah, I'm for them.
Very intelligent.
Right.
Our cats, right?
Yes, very intelligent, very expensive. So
Yes.
Yeah, recently.
Almost as bad as keeping horses.
oh my God, I don't even want to think about that.
Are we due for another
For
present?
children.
Oh,
So-
Kathy, your question is, yes, we have decided to go with June 9th to have John Conrad give a presentation that he was set to give us.
Oh,
So
good.
January.
we'll send
Good.
out an email to everybody on that. Don will send his usual invitation with a link. And I imagine that especially in the Philadelphia area, we'll probably still be on restrictions at that point. So I think it'll be a good thing for the membership to have a June meeting this year.
Yeah, for sure.
Yeah.
I'll be back
Thanks
in
again,
Philly by
Bruce,
then.
for arranging it and doing the fantastic job as program
Thank
chair
you.
here.
Thank you. Thank you.
Okay,
Great.
guys, we'll see you all next month, if not sooner.
All right.
everyone.
We'll do a happy
Stay
hour
well.
in about
Stay
2
safe.
weeks or so.
Yeah, let's do a happy hour.
Happy hour again.
Absolutely.
Okay.
Happy
is
hour
good.
again.
All right.
hey,
Let's go to an AA meeting.
We're happy. Kathy, I picked up a fat tire and thought of you.
Oh, well, thanks, Cecilia. Today it's just the water, but
Oh.
it's really appreciated for me.
Sure.
Hey, night.
Bye.
Bye, everyone.
Bye.
Take care.
Bye.
Good night.
Good night, John.
Bye.
Night.
Good night, Pete. Happy birthday.
Birthday.
Thank you.
Happy birthday.
We never did get that number.
What number?
72.
No, 74.
74, 74, that's it.
All right.
Hey, still a
All right.
spring chicken.
Night.
Good night.
Take care.